Good afternoon. This is for those who were at cross country today or those who were at Meet a Wee. I hope you had a great day. What we did today was we went through page 181, and there is another link. So if you haven't watched 181 yet, please do so. This is the second part of the lesson today, and this lesson is the one where we actually get to figure out sides and angles that are not 90 degrees. So we know typically, if you just look at my screen, a 90-degree angle, we can use regular trig functions to be able to figure out what the angles and the sides are. Today we're going to go into a little bit more detail, and we're going to look at triangles like this one that I have just circled that don't have 90 degrees, and we can still figure out what angles and sides are, but we can't use the traditional trig functions. So today I explained how we come up with this law, which is called the sine law, but I'm not going to do that for you right now because you're not in class. I think what I'm going to do is just give you the sine law, show you how to use the sine law, and this proof that's down here I will do on another day. We'll have you in after school one day, or if we have time in class I can show it to you just so you don't get bogged down with it today. The first thing though, before we go on, I just want to refresh your memory. When we look at triangles, we need to remember that the angle is always represented with a capital and the opposite side is a lowercase. Same thing here, we've got a capital B, the opposite side is a lowercase b, and the C would go over here opposite. So keep that in mind as we go through this. Now the sine law is such that we set up a ratio. The ratio is this. If I take A, which is the side opposite the angle A, and that's what I've got up here, I can set it up as a ratio, and I know that it is equal to B, which is the side, divided by the sine of that angle. And I can say the same thing. I'm going to erase all of this and do it again. I can also do the same thing with C. The side C, which is here, will be divided by the sine of the angle C, which is opposite, and I can set these all in a relationship, an equal to relationship. Now that's really helpful when I'm looking for a side or if I'm looking for an angle. Notice over here right beside it, I can reverse all of those as well. I can have the angle up on top and the side on the bottom, and that's fine as long as I stick with that pattern. The sides are all on the bottom or the sides are all on the top, or vice versa. All right, so let's move on and let's see how we put this together. So we're going to skip this page for right now, and we're going to go to page 3, or sorry, my page 3, which is 183. So to use the sine law is what I've got here. We need 3 pieces of information. The information must include both a numerator and a denominator of one of the 3 fractions. We have to have, and this is what it means, I, at this point, have this angle, C, and I have the corresponding side to it. That's great. I need to have that. This angle, I don't have the corresponding side, but that's okay. As long as I have one that has an angle and a corresponding side, then I can use this new law called the sine law. So how does it start out? Well, we're going to be asked here to use the sine law to calculate the length of BC. Now again, remember, this is not a 90-degree angle, so I can't just use regular trig functions. This is different. So what I'm going to do is I'm going to try to find the length of BC. What I will do first, however, is let's label BC little a, and we'll label the side across from B little b, and the across from C little c. Now the ratio or the sine law states that if I take A, the side A, and I divide it or put it over top of sine of the angle A, it will equal the same as B over sine B and C over sine C. Well, I'm not going to use B here because B doesn't have a value and it doesn't have a value here. So I'm not going to actually use that ratio. I'm going to do the C. C over sine C, because I have this angle for side C. So that's going to help me. I have A That's what I'll be looking for. I have the sine A, 75, and I also have the side C. So I have 1, 2, 3 pieces of information, and I will be looking for the side A. Plugging all of that in, what I've got is this. A, I don't know. Sine A is going to be 75 degrees. I'm going to make it equal to C, which is 12.50, and sine C, which is 35 degrees. Now, what we've learned, and you know this, is we can cross multiply. So I'm using different colors to represent this. I'm going to multiply these out, and then I will be able to solve for my unknown, which is my A. To do that, I'm going to start with the A, so I'm going to go A sine 35 degrees. I'm cross multiplying, and I'll cross multiply the others as well, which is 12.50 sine 75 degrees. Now, of course, I want A. I don't want A sine 35, so I'm going to divide both sides by sine 35. Divide this side by sine 35 degrees. These cancel out. Now this step I don't always show. I just go directly to whatever comes along with the A. I know that I have to put on the bottom of the other side. A equals, I plug that into my calculator, and I end up with 21.05. That is the value of A. So A, remember, was BC. That's what they asked in the question. BC, this distance right here, and BC equals 21.05. And it is in centimeters. It also told me that, maybe it didn't tell me, but usually we make sure we look at how far we take it, whether it's the 10th or the 100th column, 2 decimal places. All right, so that's how we do this one. Another question, just very similar to this. It says use the sine law to determine the measure of angle ACB. Now remember, the letter in the middle of that is the angle I'm looking for. So I will be looking for angle C. To do that, what do I have? Well, I have the angle A, and I have a side A. I must have the corresponding one to use this. Do I have B? No, but I have a side B. So what I think I'm going to do is and then of course the C is an angle, but I have no side with the angle. So that's not going to help me at all. So what I will do is I will try to find my angle B. I'll have my angle A, and then of course I can figure out my angle C by going 180 minus those other angles. So let's do that. We're going to set it up by going sine B. I'm going to go the opposite. So I'm going to put the sine on top now. I'll put B on the bottom, and that's going to equal sine A over A. That is the law that we have developed. When I do that and I start plugging in my numbers, B, we did not know what that angle was. That's what we're looking for. But across from B, I have the number 6. Sine A was 110 degrees. I misread that. 110 degrees, and over A is 9.4. After I cross multiply, and this time I'm not going to actually show you the algebra, I'm just going to go sine B equals, I'll go ahead and multiply these two numbers together, which is 6 sine 110, and I'm going to divide it by the 9.4, which I showed you up above. I would have multiplied 9.4 times sine B, but then I divide both sides by 9.4 to get sine B all by itself. Now that I have sine B, well, I don't quite. I'm going to go ahead and do that into my calculator. Remember, I'm looking for the angle, therefore I'm going to use my second function. I'm going to, first of all, calculate this out to be decimal 5998. Then I can find the angle using my second function. So angle B equals 37 degrees. Once I have that, then I'm going to go and calculate what my angle ACB is. It's 180 degrees because, of course, all the angles inside a triangle have to equal 180. I'll subtract the 110 that they gave me. I'll subtract the 37 I just figured out for B, and that will give me angle C, and the answer is 30 3 degrees. And that is the answer. Feel free to stop and start along the way and have a look at that. Okay, now next one, we are going to calculate the perimeter. So perimeter, of course, is just the outside lengths. Let's fill in this triangle initially with what they are giving us. So the first thing is they tell me that angle P right here, there's angle P, is going to be 46 degrees. We also know that angle Q is going to be 75 degrees. The only other thing that they've given me is the baseline PQ is 440 meters. So PQ is 440 meters long. Now let's identify all the sides. That capital R, that means this little side over here is a little r. This Q is going to look like this, and the P opposite will be a lowercase p. That's really helpful. Now, I have 2 of 3 angles. I won't be able to use the sine law yet because I don't have a corresponding angle and side. I have an angle but with 46, and I'm going to just show you that. I have a 46, but I don't have a side that matches. I have a 75, but I don't have a side that matches. I have a side, but no angle, so I can't do that. What I will do, though, is I can figure out what my R is. So to do that, of course, we just went over that if I want to find that angle, which is R, I'm just going to subtract those other 2 angles that have been given to me, which is 75 degrees and 46 degrees. That will equal 59 degrees. That's what my angle R is. Now that I have that, you can see that if I have this angle right here, I also have the corresponding side. Now I can go ahead and I can use my sine law. So what we will do is we will have, I am looking for Q, so let's find Q by putting it over top of sine, and the angle that opposite Q is 75 degrees. And then we also have this side 440, which we just were given, and we can put that over angle R. And angle R is sine 59 degrees. Once I have that, I can go ahead and solve for Q. Again, I'm going to cross multiply, and when I do that, I'll have 440 sine 75 degrees, and I'm going to divide that by sine 59 degrees. Get a number. Once I have that number, that will be my side. Go ahead and you can figure that out. Use your calculator. Make sure you know how to do that. I've now figured out what Q is. I have R. I need P. And that's the next one. So P is going to be over top of sine, and that angle for P is 46. And then I will equate it to the R. So we're going to have 440 again, and we'll use the sine 59 because we do know that that's correct. We were able to figure that out. P, cross multiply, and I'm going to end up with 440 degrees. Sine 46. Remember that sine 59 is actually going with the P, but I will divide both sides by it to get P by itself, so I will get sine 59 degrees over here. Plug it into your calculator and you will get 369.25. Now once you have that, you have all the sides, so you can figure out the perimeter by just taking your P, Q, and R and adding them all together, and that's what I'll do. I'll take all the numbers and add them, and that will give me my perimeter, which is 1,305 meters, and it did say in the question to the nearest meter, so you need to make sure that you take it to the ones. All right, I'm going to move on, and I'm going to do one more question, and that is on the next page. This one is actually asking you to calculate the area. So we need to remember that the area of the triangle, and we're talking about the triangle that was on the previous page, the triangle is 1/2